So you heard Frederick giving an example of science needing now massive IT resources in order to achieve its objectives. And he highlighted as well that CERN's not alone in that. LHC is one example, but there are many other examples of different sciences and different research infrastructures. And this was captured very eloquently by the Science magazine back in 2009, I think it was. When they highlighted the importance of data and that this was now fundamental to further advances in science. And that really sort of set a landmark. It brought to the attention of the funding agencies, governments, and so the importance of data in this domain. It wasn't new to many of the people sitting in this room because they knew that already from their own disciplines. Then also, there was a Riding the Wave document by a high-level group put together by the European Commission, highlighted that fact as well, saying, well, it's great, we have all this data. We need this data to advance in science and to make innovation. But to do that, we need to have some form of infrastructure. And Zoran has just explained to you the importance of having that infrastructure in place in order to satisfy the processing, the transport, and the storage of these enormous and mind-boggling quantities of data. So that sort of set the scene for how Helix Nebula came into place, along with the realization that if we did want to do this, we couldn't go to a single company and get this problem solved. It's beyond what could be achieved with a single supplier, for a number of reasons. We don't have a supplier that can follow the full scientific life cycle and workflow of these different scientific disciplines. Also, we are in a situation where it's not going to be enough, a simple supplier-customer relationship in order to satisfy these needs. There's going to have to be a tighter relationship. There's going to have to be more exchanges and more collaboration. And that set the scene for what happened with Helix Nebula. In a few years, 3 years ago now, inside the ERO Forum, the grouping of Europe's major 8 now laboratories in different disciplines, the heads of the IT came together and said, yes, we must do something about that. And out of that meeting, hosted by ESA, came out this initiative where we wrote a strategic plan for what we needed to do to see how we could address this problem. And you'll note in it a number of key points. So the idea of trying to profit from cloud technology to put in place a sustainable multi-tenant cloud computing infrastructure in Europe. Sustainable linked to the idea that it will be initially based on research needs, but we have to go beyond the public research sector if we want to make it sustainable. We are very much aware, if we're working with industry, we cannot be their only customers. So we have to tailor what we ask from them so that they can also offer those services to other sectors, the different business sectors, so that it can be sustainable and will not rely on public funding in order to survive. Yes, we want to work with funding agencies, national funding agencies. Yes, we want to work with the European Commission and so on, but we don't want to do that for the basic operation. We want to do that for the innovation aspects. Okay? And of course, it has to be based on commercial services from multiple IT companies. As I said, we don't believe a single company can offer all of the services needed. But also remember, as Frederick highlighted, we are public research organizations. We do public tendering processes. We must be able to demonstrate to our own member states that we have some competition and we have gone through public tendering. So we cannot just go to a single company and only a single offering. There must be a market for us as well. Okay. Then, of course, Zoran highlighted the point about governance. It's very important for us as well. We are essentially going to be putting our labs, family jewels, our data. We're going to be putting this data available somehow through this infrastructure. So we have to have some control over how that data is made available and how we can preserve it for many years to come. From that paper, there was this meeting that went on, and it was endorsed by an initial set of companies and research organizations, not just the ones on that paper, but number more, and you heard more about them today. And we set out a timeline with 3 major stages. So back in 2011, when we wrote that paper, there was the endorsement of this common strategy, which you saw in that document. There was also agreement on the initial partnership. The companies and the labs are going to work together in a tighter collaboration in order to perform this. And select a number of flagship use cases. We wanted to be particularly practical and concrete. So not just talking about paper, but deploying something and getting it working. And that was the flagship use cases. And putting in place a basic governance model where these companies and research labs can work together to achieve some initial results. So that led us into the pilot phase, which has lasted 2 years. We're at the end of this pilot phase now, where we have deployed the flagships, and you'll be seeing those this afternoon, and done an analysis of what's the functionality required, what's our performance requirements from each of those different flagships, and the financial models we can use to make it sustainable as well, with the end of working towards what we call an open market for science, where we can put in place all of these different elements from the public sector and the private sector, put them together to build a self-sustaining market that will continue to grow. So the really long term is to create this multi-tenant open marketplace for science. And what you're seeing today is basically the first step of that, to put that in place, right? Where we bring together, yes, the data, the scientists, the researchers. You've heard from Frederick the enormous numbers of young engineers and researchers are coming through laboratories such as CERN and will help industry as well for these innovations. And of course the downstream industry and SMEs as well, and you'll be hearing from some of those SMEs later in the day, to walk towards this common goal, really to build up a whole ecosystem which can grow and serve not only the research area, but many, many sectors. So there's the initial partnership. This is put together, some key elements to that. I've mentioned already the scientific and space organizations. So they commit resources. By resources, I don't mean just the data. I also mean the personnel, the expertise, and their own computing resources in there as well. And also, they make a commitment for these flagships to sponsor those flagships. They realize there's no free lunch. They realize they have to pay for these resources, and they are contributed towards the cost of the resources they're consuming through Helix Nebula. On the other side, we have the IT providers. They're also committing resources, and again, not just hardware, but their software, their personnel, and so on. And just to highlight as well that all the technical developments that you will see that have been made inside Helix Nebula today, they are funded by those companies themselves. They're not funded by the demand side. We're paying for the resources we consume, and they're not funded by the European Commission. They're funded by the companies themselves, right? And of course, we have to see how they can work together to share those investments, because if we want to make it this big, it's going to make significant, it's going to require significant investments, and try to put together some forms of standards there in a progressive manner, making use of de facto standards when they're available. Of course, the SMEs I mentioned as well, they're a lot more agile. They can bring in expertise and innovate new services, building on the data and infrastructure that's there already. And as I said as well, working with the European Commission, which has supported the Helix Nebula Initiative with a support action during FP7. And in particular, it's very important, and we've got a lot of benefits of working with the European Commission in terms of policy strategy and helping us work as well with the member states. So in terms of those flagships, we picked 3 initial flagships. From CERN, as you said, you've seen Atlas already. So what we're actually doing is we're taking some of the simulation, because when we run an experiment such as CERN, you have the theory to start with, Mr. Higgs, who got the Nobel Prize. You have as well the experimentalists who are going to deploy it and build the machine. And we have at the same time the data coming out of that machine, and it has to be compared to the simulation to make sure that what we're actually seeing is correct and it adheres to the theory we're talking about. So we're taking some of the simulation code which has been used, put together by Atlas, and we've been deploying it as an application on the Helix Nebula infrastructure. For EMBL, there's the area of genome analysis, which is an enormous area and growing all the while, with massive importance for science, for the population as a whole, for other industries, think of crop industries and things like that as well, and looking into evolution and biodiversity there as well. And then this was important as well. was the European Space Agency. Look at the sort of Earth observation platform, which is building up and helping in terms of focusing on earthquake and volcano research, and has the biggest potential in terms of potential usage by downstream industries and impact in the different business sectors. So they've all been chosen for different scientific challenges, the different ones. The CERN one above all is scale. As Frederick, you saw the numbers coming from Frederick, and he mentioned Open Lab, and we have a motto inside Open Lab: you make it, we break it. And we can break anybody's data center just with the amount of data that we can put into it. So the IT industry likes working with us because we can test the hell out of anything they produce and show if it will scale or not. Genome assembly from EMBL is very interesting as well, because there are potentially issues of data security around this. There's also the questions of putting together complex workflows as well. And what's very interesting with ESA, of course, is the point of bringing together a whole user community, different user communities, and sharing these data sets, linking multiple data sets together, and building downstream services by other industries as well. So they're all stretching in one way or another what's possible with those cloud services. And if you look at that, that tells you what I've just explained in each one, why we picked those ones, and how they hopefully, as a set, address all of the key points we want to be able to shake down this cloud infrastructure and see if it will really work for us. But again, don't forget the big picture. What you're seeing today is step one. It's the basic elements in place so we can show it's working. But we want to work towards this whole idea of the open science market, which is an ecosystem where there are a number of data suppliers, public and commercial, and there are a number of ways we can transform that data, store it, transform it, add new value to it, transform it into new services, and make use in different industries. And those consumers can be not only the research sector, public research sector, but many other sectors as well. When one thinks of information coming from satellites, combining it with other sources as well, then one really starts to see the potential value that can be put together. The other thing I mentioned was the governance structure. Well, I said we're practically minded, so that is the governance structure we've been using in Helix Nebula for the last 2 years. Very, very simple, right? We have the servers, the service providers board. They've been working on the technical aspects like the technical architecture group, the service architecture group. And then we have the users board sitting together, and we have a mixed management team, half of which are from the user side, half of it from the supplier side. And we've been working together. Certainly not perfect. But it's allowed us to go from 20 to double, so that more than 40 members inside the consortium at the moment. And all that work has been covered with a non-disclosure agreement, because the companies are exposing to us many of what might be considered their confidential information. So we have to treat that with respect, and respect those parts as well. And that's why there's an NDA around it. But we're saying that's the basic one. And if you look inside your handouts, you'll find there's an executive summary for where we think we can go in the future at potential governance models, because it's worked up to now, but it's worked for doubling the scale. Will it work if we start multiplying it by orders of magnitude to 400, 500 members inside such a marketplace? Not sure. We have to see what would have to change in the future, and that's part of that study you've done there. So this is the situation today. Here you see some of the members. You'll hear more about those this afternoon, those members from the supply side and the demand side as well. The three applications having been deployed. We also did a call for new flagships or new applications deployed. We got, I think it was about 15 of them. We went through a selection process, and the one that's now closest is just starting to be deployed. So that's why it isn't shown today, because it hasn't actually deployed, and we don't want to show you something which isn't running yet. It's starting to be deployed, and that's from Barcelona, the port informatics, for the neuroinformatics domain in Barcelona, where they're taking brain images and basically reducing the time it takes to get a decision back to the medical staff, and using the Helix Nebula cloud infrastructure in order to do that. Okay? So you'll hear more about that at future events as we get it in place. We have parts of the strategic plan already in place, and you'll hear more of those as we go along. Okay? So what you'll see the rest of this afternoon is, of course, as I said, it's the first production environment. We're calling it a production environment. We've been testing it a lot for many, many months as a collaboration between the companies and the research labs. And we see it very much as a basis for expansion in the future towards this market that we've talked about for the future. Okay, you'll see the scientific applications, which have already been deployed. You'll see those later this afternoon as well. And we'll give you some outlines about the future directions. Okay, so with that, take any questions that you might have. No? No? Okay. Then, okay. So now we have a short video which tells you a lot more eloquently than I do what I've just said.
Helix Nebula Marketplace, a step towards federated information as a service. Europe has a wealth of public and private sector IT service providers. By bringing them together, we can create a groundbreaking open platform for innovation. This opportunity is a key driver behind the Helix Nebula Initiative. Helix Nebula is a partnership between science and businesses. It has built a cloud infrastructure for science in Europe using a federated approach. It delivers easy and large-scale access to a range of commercial and publicly owned cloud services through the innovative broker technology deployed within Helix Nebula, the Science Cloud Initiative. The information as a service model ensures efficient service provision. The supply side has been developing a common front end to its various services so that users can select from a range of federated cloud providers and services and invoke them in a uniform way. Each partner remains fully in control of the implementation of its data policy and usage of intellectual property rights. These services are formed into the Helix Nebula Marketplace so that users can compare, choose and match services together. Over the last 2 years, Helix Nebula has broken new ground by testing flagship applications from CERN, the European Molecular Biology Lab, and the European Space Agency. We selected these pilots because they have different set of requirements in terms of cloud resources. CERN is focusing on the Large Hadron Collider physics experiments, where computing capacity needs to keep up with the enormous amount of data generated. EMBL is working on annotating DNA, which requires a lot of run processing to decompose, recompose and analyse the DNA. ESA is a supersite exploitation platform which focuses on volcano eruption and earthquakes by federating data and users. Testing demonstrated that Helix Nebula can provide high quality and secure cloud services and reduce processing time. Today, Helix Nebula welcomes the participation of scientists, data and service providers and SMEs to create a marketplace where we bring together science and businesses, establishing a European value-driven ecosystem and a user community that puts Europe in the driving seat. To find out more, visit our website www.helix-nebula.eu.